Now let's look at horizontal asymptotes. You've done these in pre-calculus, but now we're going to use a more rigorous calculus definition. The line y equals L is a horizontal asymptote of a graph if the limit as x approaches positive or negative infinity is equal to L. The key here when I ask for an asymptote is you need to give me the line y equals L. This is the asymptote. Now remember, the limit as x goes to infinity of c over xc is 0, whether it's positive infinity or a negative infinity. The line y equals 0 is the horizontal asymptote for these. So you need to be careful because this one students tend to forget about. Now, finding the horizontal asymptote, we just discovered that that limit is 5. So the horizontal asymptote is y equals 5. And I want you to write HA, horizontal asymptote, put a colon, y equals 5. Now sometimes these are a little bit more of a challenge, and sometimes you can have two horizontal asymptotes. So let's look at this function right here. And let's look at the limit as x goes to infinity of 3x minus 2 over the square root of 2x squared plus 1. Now we're going to find some other ways to do this later, but right now there's not a lot we can do without going back to some pre-calculus tricks that you used. The first thing, as long as x is positive, then you can write x is equal to the square root of x squared. All right, now I'm going to divide both numerator and denominator by x. So this is the limit as x approaches infinity of 3x minus 2, and I'm going to divide this by x. Now I'm going to divide this one, square root of 2x squared plus 1, by x as well, but instead I'm going to use the form square root of x squared. And I'm going to do this so I can bring it inside the radical. So this right here becomes the limit as x approaches infinity of, what is this? This is 3 minus 2 over x divided by, I'm going to bring this whole thing inside the radical, so this becomes 2 plus 1 over x squared. Now, as I take the limit, I can see this term right here becomes 0, and this term right here becomes 0. So this whole limit is 3 divided by the square root of 2 as x goes to positive infinity. Now I'm going to switch colors and let's look at what happens as x goes to negative infinity. Now, when x is negative, I can write that x is minus the square root of x squared, because x has to be a negative number, but the square root of x squared, you remember, the square root of x squared is the absolute value of x. And so that's the fact I've been using. Now we're going to do the exact same thing. Limit as x approaches infinity, but this time I'm going to divide by x again. So it's 3x minus 2 divided by x divided by, and this time I'm going to use minus the square root of x squared in my denominator. So we have a negative square root of x squared. Now I'm going to rewrite this as a limit as x approaches infinity of 3 minus 2 over x divided by, now I'm going to have this negative sign out there, so I'm just going to leave it out there, square root of 2 plus 1 over x squared, so that hasn't changed at all. Now this limit, as I apply this limit, and I'll be a little bit more rigorous here, becomes 3. This limit is 0. I've got a negative sign out here. This is 2 plus 0. So this is minus 3 over the square root of 2. So now I have two horizontal asymptotes. This horizontal asymptote is y equals minus 3 over the square root of 2, while this horizontal asymptote is 3 divided by the square root of 2.